Okay, back to it. Great. So yeah, today with this mysterious title, we're going to talk about the Dataflow template for Neo4j actually. And what's the title? I don't know. There was a Beatles documentary back then when I had the idea for the talk, and I ended up with that. It might remind you of a song starting with Lucy and ending with Diamonds. It's kind of has the same reason. But we're not here to talk about music. So I'm Florent. I'm part of the Neo4j connectors team. And our mission in this team is to make data movement from Neo4j or to Neo4j as smooth as possible. So that's one of the pillars. The other pillar is to meet users where they are, regardless of their cloud provider or whether they are on-prem or not. We're trying to offer them solutions and, in a way that is as simple as integrate as possible. So, and part of that, was to help some customers and users using Neo4j as a sink. So really export data to Neo4j from within Dataflow, and that's how the project came to be. And first, since it's a beginner-friendly talk, I will start just with the basics. I'm not going to spend too much time on it, but still, talking about what's Neo4j and a graph database in general. Then Neo4j in the cloud, because in that, for the demo I'm going to show towards the later part of the talk, I'm going to use Aura. So I'm going to talk about that a little bit, and then we'll focus, obviously, on the no-code imports, which is almost true with the demo, and I will explain why later. It's not 100% no code, but close enough. And that's going to be using the Dataflow template for Neo4j. All right, so let's embark onto this journey together. And here we go. So, you will probably be familiar with this. And if not, don't worry, I will take enough time to explain it. So a graph database is made of nodes. So nodes have 0 to many labels, at least usually one, and they can have many key value pairs that we call properties, hence a property graph model. And the label part came a bit later in the history of Neo4j, because that's a way to group similar node shapes really together. That's just as you would put a label on things, really. Then you also have a way to link them together, and those links are called relationships in Neo4j parlance. Relationships have always one start node and one end node, or even though it could be the same node, right? You can have self-linking relationships as well. They must have a single type, not 0, not many, just one, and a direction that you can choose to ignore or not. Like if you have bidirectional things, for instance, I'm a friend with someone on Facebook. I don't know, I've not used Facebook in years, but I assume it's still the same today. If you're friend with someone, that someone is also your friend, right? So you don't need to create two relationships in that case. You can just create the relationship with an arbitrary direction and ignore it at query time. And just like nodes, relationships, are first-class citizens, and they can have as many properties as they want, so key value pairs again. And one important part also that you need to be careful with when you're modifying your graph is that the constraints of having one start node and one end node is always true. So if you somehow delete a node and forget to delete a relationship, then the transaction in which this occurs is going to be invalidated. So that's one of the invariants that is preserved. The transaction will roll back because of that error. And if you're coming from the relational database world, so this is kind of a quick comparison between the two approaches. Let's say you have people, so in a person table, and they belong to groups. A person can belong to different groups, and a group is made up several people, right? It's made of several people. So the way you would do that in the relational world would be through what we call a join table. So if you're familiar with that, you probably worked into these N-N relationships, as we call them, before. So join table is no foreign to you. However, I showed this slide a few years back to a couple of non-developer colleagues, and they had no idea what I was talking about when I was trying to show the left part of the slide. They were like, what is a join table? I still don't understand it. So it's funny because it's very ingrained into our developer mindset, into our technical minds, but it's still not very obvious for non-technical people. And on the right, you have the equivalent, right? So you have one person belonging to three groups, It's not necessarily the only possible way to model this, by the way, but here I'm just taking like a very intuitive way to do about it. In some context, it might not be the best way. But anyway, you will have a node person connected to 3 other nodes. Those 3 nodes would be groups. So group label, person label, and they are linked together directly through relationships. And that I had absolutely no difficulty whatsoever to explain to my non-technical colleagues. And I think that's also one of the power when you start modeling with Neo4j. I'm not saying the models are always going to be the best ones. Every model is wrong in a way, right? But some are just stronger than others. But this ability to draw things more naturally is also one of the big strengths of Neo4j, I think, in general. And it makes it much more accessible to people. Obviously, there are technical considerations to take into account when you go to the production journey, but that's beyond. This is not a graph modeling talk, so I'm not going to dive into that. I just want to make sure you get some general model in mind before we dive into importing data, because you need to understand that data needs to be modeled as a graph at some point. And then we're gonna, one of the main way to interact with data, Neo4j data, is through the Cypher query language, which is a graph pattern matching language. So you describe patterns, and then the Cypher execution engine will try to understand what's the best way to find the data you're interested in. So in that case, I have like a couple of actors, so 3 actors to be exact, that I'm showing on the slide. I have 2 movies. Some actors acted in the movies, some actors directed the movies, maybe both sometimes, like Keanu Reeves, for instance, directed and acted in the movie Man of Tai Chi. And so in that case, I'm just asking Neo4j to find me all the names. So if we start with return, I'm asking for the names. So the actor variable is bound to a node pattern with a label actor. So the names of the actor nodes that acted in a movie, the movie is called the matrix. The movies, maybe there are several ones, right? Unless there is a uniqueness constraint on title, maybe there are several ones, we don't know. And what's going to happen, basically, roughly speaking, obviously, just an illustration, it will find the starting point, which would be the matrix movie, and then expands. So expands through relationships, so those acted in relationship, and finds the neighboring actors based on the match patterns, and then projects the name properties of those actor nodes. So that's roughly speaking how it works and how we can actually find or insert data. And obviously the data flow template for Neo4j relies on Cypher. It's gonna create Cypher statements for you and run them against a target Neo4j instance. If you want to learn more about, graph data modeling, the Cypher query language, data import techniques, and more, there is always Graph Academy. So I really invite you to join. It's completely free. The courses are actually very extended, very detailed, and touches many different super interesting topics. So if you want to become a Neo4j champion, I really invite you to attend those courses, and you will learn a lot. They are very practical, very well done. So yeah, give it a try. And so now that you have an idea, at least, of what Neo4j looks like and what its paradigm is, let's talk a little bit about how you can actually run it. So here, for the sake of the data flow, and for my demo, I'm going to use Neo4j in the cloud, right? So data flow itself is a managed offering of Google Cloud Platform, but Neo4j is not tied to Google Cloud. You can run Neo4j in Google Cloud, so that's not an issue. You can find it in all the major cloud providers. But we also have a managed offering called AuraDB, and you have different tiers. So there is a free tier, which is completely free of charge, no credit card required. And then depending on the level of operation constraints you have, you might switch from Pro to Business Critical to maybe Virtual Dedicated Cloud. So those are the current tiers. Business Critical, so Enterprise has been renamed recently to Virtual Dedicated Cloud, and Business Critical is really sitting in between Pro and Enterprise. So that's you've really got a fine-grained selection of Aura instance if you want to. Then for your data science needs, you've got Aura DS, which is Pro or Enterprise, and I will show it a little bit in the demo. And finally, if you don't want to go through the UI all the time, you have the nice project called Aura CLI when you can, create and update your instances just with the CLI, so you can automate that in any of your toolings, because there is also an Aura API under the hood. And I'm going to use that again in the demo. And so let's talk about Dataflow template for Neo4j. So as I said earlier, Google Cloud Dataflow is a managed data processing service on Google Cloud Platform. So here I'm going to put my developer hat, and really the way I would describe it to other developers would be that it's basically a runner for Apache Beam pipelines. And so the next question you might ask, okay, what is Apache Beam? So I'm going to come to that. But the nice thing about Dataflow, so it can be very flexible, but it also offers predefined templates. So that way you don't have anything to write really. You just have to select the template you want for the import recipe in a way, or for the data transformation recipe you want. And then you will just have to fill in a few parameters and get running, and then you will get your Dataflow pipeline running for you without having to program anything. So that's the template part of Google Cloud Dataflow. Dataflow itself, you can actually programmatically define your pipeline and run it on Dataflow as well. But yeah, so I said Google Cloud Dataflow is just an Apache Beam runner, which is great, but what is Apache Beam then? Apache Beam is actually a framework that unifies streaming and batching together, and the beam, which is batch and stream. That's a play on those two words. And that allows you to define directed acyclic pipelines. So you can have different branches joined at some point, writing to different sources, different things. And that's what Dataflow is using, and that's why Dataflow templates are using, right? Templates are just an abstraction of a Dataflow, so it's not going to change the underlying framework. And so our template supports two kinds of sources, BigQuery sources. So BigQuery is like this storage service on Google Cloud. And you have cloud storage when we can also fetch text files, so think CSV files on cloud storage. And so you can have these two types of sources, and then you will give a declarative. So if you've watched the talk I've given with my colleague Ali, and if you have not, I recommend you do, on import spec, that's basically the formalism we use to describe the pipeline you want, the import pipeline you want for Neo4j. So it's another abstraction level. And that's not tied to Dataflow in particular, but Dataflow is one product that's currently using it on top of some other customers interested by the import spec formalism. But we'll see it in a bit. And so you just declare which sources you have, what graph data you want out of it, and then it will automatically execute that pipeline for you and run there. And the nice thing about the Dataflow template for Neo4j is you do not need Cypher knowledge. I mean, not necessarily. Again, you will see in the demo there is a bit of Cypher, but that's because of an issue that's going to be fixed soon. So the next iteration of that talk, you won't see any Cypher. But one thing that remains true, even in that demo, is that you don't need to know anything about Apache Beam. So yeah, you just need to declare, here are my sources, here are my targets. I'm going to go back to that. So here are my nodes and relationships, and then everything will run for you. And so, yeah, to give a bit more precise vocabulary here, so we have sources, as I said, but we have targets. So I said that word, it escaped my mouth a few seconds earlier than I wanted, but you have targets, so node targets and relationship targets and custom query targets that will basically be ways to define how you map a source batches of records to nodes and relationships. And then it will run in batch against the configure database in a sensible order, because that's important, right? You've probably seen, if not, I advise you do, the previous talk by Christophe on locking. And so, yeah, you don't want to run in arbitrary order, because, to create relationships between two nodes, you need to lock on those nodes. So you're trying to modify those nodes as well. At the same time, then you're going to run into issues. So yeah, Basically, all this complexity is kind of hidden away as much as we can in the template, so you don't have to worry too much about it. We have implicit ordering and explicit ordering as well for cases you really need to care about it. And yeah, we try to have, you know, a good guess of what's a batch. So we try to do batch insertion. So we try to have a good batch size. We try to be respectful of the, you know, target server memory and whatnot. So basically, we're trying to follow all the good practices around imports with that surfacing into the configuration surface. We really want to have this import spec to be as declarative as possible without diving into the nitty-gritty details of how to actually run it. And so how it looks like concretely, we'll go and we'll do that in the demo, right? You go to Google Cloud Dataflow, you select the Neo4j template, you give it two things: the specification of your import. So implicitly here, the sink will always be the Neo4j instance you configure. And how you configure that Neo4j instance is basically through a specific resource. So either a file hosted on GCS, that will be basically a JSON payload with a URI, username, password, possibly database, or a secret ID. If you don't, I mean, GCS URI doesn't have to be, the GCS resource doesn't have to be public, but it's still plain text, JSON plain text. If you don't want that, we also work with a secret manager. So the second form to supply the configuration to Neo4j is a secret ID, and the secret manager will automatically retrieve it. But the shape is the same. It's still JSON payload, but encoded as a secret. And once you have these two things, so the import specification on one hand and the Neo4j location and credentials on the other hand, then we're ready to roll and we can actually see it. So let's try. So what I'm going to do, since it takes a little time to provision, what I'm going to do is first, so let me first go there. So we'll go to Dataflow. And we'll create a job from templates. You have several abstractions here, and you can create jobs directly yourself as well. But again, it's about the template. So what I'm going to do is I'm going to do a London network import, so transportation network. I'm in Europe, so I'm going to pick something close to me, like Paris, which is quite close, nice. And there are many templates, but here we were interested into the Google Cloud Neo4j template, which abstracts BigQuery and CSV sources on GCS. Because of a glitch, you either supply a secret or plaintext file on GCS for the connection, so it's either or, right? So none of them are individually mandatory. They don't show up in the required parameters section, even though one of them is required. So that's a glitch in the UI that's going to be fixed at some point by the Dataflow team. But yeah, for now, the only required parameter you can see is a job spec. So I already uploaded it, and then I will walk through it after I start the import, I promise. So many things, but here let's pick Notes 2024, and I'm going to pick the spec, and I'm going to show what spec it is. And then you have, unfortunately for now, to go through the optional parameter list. So either you supply a path to the connection metadata, or you provide the secret ID that you got when you created the secret with the JSON payload. To keep things simple, maybe not the most production-ready way to go, but to keep things simple, I'm just going to pick the Aura configuration file I uploaded as a plaintext file. Again, this is not public, so the risk is limited, but I understand why people rather go with the secret ID approach. So I'm going to pick that. And all of this you can safely ignore for now, for the sake of the demo, and we're just going to run the job. And we're going to come back to the slides, and then I will also show. And so, as I said, we'll have basically in that case sources from BigQuery, and we run that. So that's basically an Apache Beam pipeline, and we'll have a few targets that basically gonna be mapping transforms in terms of Beam, and so it's gonna transform on the input records, and they will output writes to Neo4j. So the thing here, it will be Neo4j. And those are the attributes we have. We have BigQuery source or text source. Yeah, actually, that's a typo. That's a text source. and 3 kinds of targets, as I said, which all are linked to a source and all have a name. Then the node target have labels and property mappings, relationship as a type, and all the property mappings. Aside for query target is just a query, basically query run for each batch of records. And yeah, the import spec basically shows that. Actually, I can replace the slide and show this one. Live sliding, live slide editing. But yeah, you have those targets that maps from batches of records from the source, and then you have one-off actions that are not related to any source records that are basically run one-off at different stages of the import. But let's see concretely what it looks like. So let me go to distraction-free mode. Concretely, what I have, so I have this BigQuery table called London Station. And what I'm going to do, so the source is named station, the BigQuery source is implemented at the Dataflow side, because if you've seen the import spec talk, you know that import spec does not define any sources by default, because there is a source plugin system. So the type BigQuery is implemented and supplied on the Dataflow side, not the import spec side. And what we do here, we expect a query, a SQL or SQL-like query, and it will basically check these fields. So that's one source called station, the other one is tube lines, that basically between two stations and with a name. Then what we do, so that those are our sources, which is nice, but let's move on to the targets. What do we do with the sources? So if you look, the station source is actually used in the target that's called station. Here we decide how we want to write the nodes. So either it's merge, so upsert in some other solutions it's called. So it will try to find it. If it doesn't find it, it will create it. The other option is create. So it will create and does not try to find it first. So that might lead to duplicate if you're not careful. The source transformation bit is a way to customize the initial source query. So in that case, it's a simple select, but we'll add a group by that will make sure that those fields are actually unique. Then the node will have the station label and will have those mappings. So the source ID, so the fields obviously here come from the query directly, right? So we have all these fields. So the ID will be renamed to something a bit more, conventional in terms of case. Same thing for station name and whatnot, and float and string. The key will be station ID. So station ID based on the property names this time, because the schema is a Neo4j concept. And we'll create as well indices just to make sure that our subsequent queries will be efficient. So based on the station name. And finally, so that's where the no-code part of the title is a bit of a lie. Ideally, we would have a relationship target, but there is a slight limitation that will fix soon. So instead, what we've done is do a custom query to link stations together, because a station is connected to another one. And what we do is use a custom query, and there is this magic parameter here. So that's basically the current batch of records. That query will be run as many times as there are batches to process from the source being tube lines here. And what we're going to do, so the row is basically a map, and the keys of this map are the fields of the query. So in that case, tube line from station to station. And so what we'll do is we'll match the station with the name corresponding to the to station, same with from station, and then we'll link them together, and the line will be based on the tube line attribute. But we want, and that's why there is explicit ordering as well, because with relationship target, you have this implicit ordering executed for you, when a relationship target will always be processed after its start node target and end node target. Here, because it's a custom query, we are not parsing queries in Dataflow, and usually we don't parse queries in our connectors. So it's a black box. We don't know what it depends on. So you have to explicitly say it yourself, and you can depend on several things. That's why it's an array. So here you will depend on another target, which is called station, because you don't want to link stations because before they are all processed. And so once we have that, basically that's what we just run. And so let's see where our import ended. So let me exit the distraction-free mode. And if we're lucky, it's all over. And so Dataflow UI is nice because it basically shows you how your actual BIM pipeline is materialized as. So I'm not going to go into the details for everything, but you can see that it basically had some metadata. So basically trying to figure out the schema for the source stations. Then it tried, so this one is for the station node, so creating the station nodes. Then we're waiting for, remember, waiting for the stations to be done. We also fetch metadata in parallel for the tube lines. You remember, we have two sources, so we have two schemas to figure out. And so once that's done, so when our station nodes have been processed, then we can finally move on to the custom query part. After the writing, obviously. So first metadata, then writing. And then finally, once the waiting is done, we can process the tube lines. So first it will wait, and then finally execute the query as many times as necessary. And so if I go to the Aura instance I configured, which is this one, what I'm going to do, because it's taking a while, we'll see if I have enough time to check it, but I will clone it to AuraDS so that I have some data science functionality into Bloom, which is quite nice. But yeah, it's probably gonna take a while. So let's see if I have. First, let's just explore here without data science bits. But for now, I need to repeat the password, and we can explore a little bit. But I could stop there as well, right? Because my import is done, and it's an import talk. But let's prove it actually. So I have stations connected to stations, right? So stations connected to stations. That's good. So let's run this and zoom out a bit because it's showing me one station in particular, but coordinate layout. Maybe let's switch to any. There is a glitch. I don't have time to troubleshoot right now. Let's try again. Yes, better. And with the coordinate layout, which is not the default one, by the way, so it's picking up the longitude and latitude attributes of the stations automatically. Then you get a nice view of the London network. And if we have time, I'm not sure we have, but let's see if I can go to my DS instance instead. Let's see, it ceased to be unblocked. So this time I need the password for my Aura DS instance, and maybe I can show some central stations, for instance, through centrality algorithm, which is just, one analysis that I could do. I could do many more, right, now that I'm in the Neo4j world. So I'm just going to do this. Again, station, any station, then display this, and zoom out. Yeah, not sure why. Let's run again. There is maybe some caching issue. And now I have this graph data science things, which is nice. So I'm just going to pick, for instance, a degree centrality. So to see which one are the most connected in general. And I'm going to use, yeah, those look fine. So I'm going to apply the algorithm, and I'm going to change the size a little bit. So size scaling, which I'm going to change to make the contrast a little bit more visible. Whereas the size here will be just a quarter of what it was. And then if I zoom in a little bit, we can see some bigger dots than others. For instance, Liverpool Street is quite connected, or Paddington, etc., etc. So that's one basic analysis, obviously, of London stations. We could do many more. But yeah, that's what's unlocked once you import data in a no-code, or in that case, low-code fashion. And yeah, just to conclude, because I think it's time. So at this point, we only support BigQuery and CSV sources. There is nothing preventing us from adding more source types. It's also based on demand. So if you're interested in more sources for this Dataflow template, please let us know. We have also a few ideas for smarter parallelization, because currently we default to make sure that some relationships are always after their nodes, but there are also smarter ways to make it parallel. And we also try to not parallelize relationship import, but there are ways to make it smarter, especially with import spec, which brings us a wealth of metadata about the import we want to do. We're also working on improving data conversion. We have different sources. We don't have all the same type system at the source level, so converting is sometimes harder. And maybe at some point we'll have a template for exports, who knows. And I'm a little bit over time, so I'm going to stop there. Thank you, everyone. And I will see you all later. Thank you.